Hello, my name is Logan. Thank you for joining me. Today we'll be talking about regular expressions in JavaScript. First thing you might be wondering is, what are regular expressions, or RegEx as it's commonly abbreviated? Well, regular expressions generate patterns that can be used to match characters in a string. And think non-trivial validation, such as email addresses, credit card numbers, whether URL is valid, or other forms of data that need to be formatted. And this is because oftentimes we aren't able to use the default string methods because they aren't powerful enough to validate what we want to do. They're perfect, though, for more trivial validation purposes. So the second thing you should know is how to create a regex, and there are two ways you can do this. The first one is you can define one and assign it to a variable without using the constructor, and it's just like this. They start with the forward slash, enter your regular expression, and then close it with the forward slash. The other way is you can use a constructor of the regular expression object, which is pretty much the same thing, except this time you enter the regular expression as a string instead of using forward slashes. And the benefit of using the constructor is that at runtime, you could get something like user input, and which would probably be in the format of a string, and then you can just feed into the regular expression function. Whereas the first one, you could not do that because it's not a string. So next thing we're going to learn how to do is use regex. And there are two ways to do this. The first one is using the regular expression methods itself. And the other one is you can use the string methods that you're used to, except in place of using a string inside of them, you can use a regular expression. So first, let's look at the regular expression-based methods. Let's say we have a string that's just A, B, C, D, E, F, G, B, C, and then we're just going to call the execute function on this, and this is going to match the regular expression we have to the string. As you can see, the regular expression is just ABC, and so what this is going to do is it's going to simply look for ABC in this string, and we see it here at the beginning, and so it's going to return just the ABC part. You can see our input, and then we just have the ABC part, just the part that matches. Test is similar to exec, except it doesn't return the string that we're matching. Instead, it'll return whether it exists in the string. So this would be something you'd use more for validation. Result. And you can see the result is true here. The next thing we're going to look at is the string versions. So this one, instead of starting using the regular expression object, we'll be using a string object. So we can do result equals string.match and then RE1. And this will return the same thing as before. The only difference is that now we're starting with a string. And something to note about the match function is it will return a list of the matches if you specify a global flag, but in this case we don't, but we'll get to that later. The next function is the match all, and this will, instead of returning a list like match does, it'll return an iterable. So if we just we set res equal to a list, then we can just iterate over the matches. Here we're adding a G to the end of the regular expression, which is a flag. We'll cover this later, but basically what it means is it'll search through the string for from the last place it left off at. So when it first finds ABC right here, then the next time we call match all, then it will start at the end of ABC there, and you'll see it will move forward and it'll find the ABC at the end of the string, rather than starting at the beginning every time and only finding this ABC. So we'll set the results equal, or we'll push on just so we can see that it finds it multiple times. You can see down here result, it's a list and it has ABC twice. The next thing we have is replace, and it works the same as match, except instead of returning the match, it'll actually replace the string that we have. So let's try that out. We're going to replace the first occurrence of ABC with an uppercase ABC. And you can see that right there. And then replace all is similar to the match all. We'll have to use a global flag for this, but it will replace all occurrences of ABC with a capital version. So I'll just copy this over. I'll replace all, and then pass it ABC, but with a global flag. And then you can see right here, both the lowercase ABCs were swapped with the uppercase version. The next thing we might want to do is search a string for whether or not the regular expression matches as string, and this is kind of similar to the test, except we're just using the string function version. String.search, and then we just put in our regular expression, and this will return the instead of returning true or false like test does, it'll return the index that it finds the regular expression if it exists. However, if it doesn't find the index, then it will return -1. Here we can see the result 0, and that's because ABC, the first occurrence of ABC, starts at index 0. And the final thing we can do is split the string. So let's say we want to split it in the middle here at CED. And we would call the string.split function just like you normally would. And this time we'll pass it in regular expression that we want to split it based off of. And we can see we get AB delimited by CED. And so then the second entry is FG ABC. And so these are the basic functions that you'll be using with a regular expression. You either use the string function or the regular expression function itself. So basically what we've been using is just straight literals, but regular expressions support much more complex behavior. And the first thing we'll talk about are quantifiers. And quantifiers are when we want to use more than one of something. So the first quantifier we'll look at is the star. Sometimes it's often referred to as a clean closure, and it means 0 or more of whatever's to the left of it, or whatever is immediately to the left of it, rather. So let's say we have a string that equals 0, 0, 0, 1. We want to match all those zeros and the 1. We'll have to use a clean closure. So we'll go. We'll use the string function, match string function for this. And so we want all those zeros. So we'll start with 0, add the clean closure, and we want to end in 1. So we'll add the 1 like that. Run it, and we see the result. We get them all. The next one is similar to the star, except for matching 0 or more, it'll match 1 or more. So let's say we'll just swap this to the plus, and we can see that it's the same output. But what if we move this one, we don't have any zeros? Then you can see the result's null because it didn't match anything. But if we change this back to a star, you can see now we get 1 because it's 0 or more zeros. The next quantifier is the question mark quantifier, and this is for 0 or 1. So if we have string equals 1 and we perform the same thing here, it'll match it because it's 0, 0 or 1, 0. And then if we add a 0 here, it'll match it there again. And then now what if we add multiple zeros? It'll also match it too. But it'll be these zeros right here at the end rather than a prior 0. And then the next thing we can do is perhaps we don't want to specify 1 or more, 0 or more, or 0 or 1. We can specify an exact amount using the syntax here with curly braces. So we can do result equals string.match, and we'll still want to do zeros, but let's say we want to match 2 of them first, and then we'll keep 1 too. And so this should return 2 zeros and then a 1 if we have that match. We do, so we get 2 zeros, 1. This next quantifier is for at least n of whatever precedes it. So this would be at least 2 zeros, and so we should say should get all. Sorry, I need to add the comma. Should get all the zeros and then the 1, and this would be the same as the plus quantifier if we just have a 1 there. Something to note about these two is that this n is for positive, which means greater than 0. Same with this n. This n is different. It's 0, and then m has to be greater than n. So m would have to be positive. But what this one does is it's a range. So it means from either n to m appearances, inclusive. Let's say we wanted 0 to 4 zeros, then we would put n as 0 and m as 4. Look at that really quick. We want 0 or 4, and we will still want to end with a 1. And if we run it, we just get the same thing as the previous time, just because the matches all 4 zeros. If we had 5 zeros, it would still match it, but it would not have the first 0 there. Now, something to note about the question mark is that it makes these quantifiers become non-greedy, because right now when you have x star, it's going to try to match as many zeros as it can and then a 1. Same with the plus. It'll try to match as many zeros and then a 1. What the question mark does is it'll do as soon as it sufficiently matches whatever it needs to, then it'll stop right there rather than greedily going forward. And so an example of this is if we have angular braces string like this, and we only want to match the first pair, then we can do that. But first, let's start out with matching all the pairs. So we just have our braces like this, and then we'd have our plus because we want one or more, and we'll terminate like this. So this is saying we're starting with the left angular bracket, and then we want one or more of the right angular brackets. And you can see we got them. But what if we only want just that one? Well, plus is greedy, so we want to make it non-greedy, so we'll add the question mark after that. And we can see that it only matches the first one. So we'll get the first angular bracket. We'll go on to looking for one or more to the right. We'll find one, but this question mark says we want 0 or 1. And since we found 1, we'll stop there because that's all the question mark lets us do. Another thing to note too is that the star operator itself is a special special. So is the plus, the question mark. What if we wanted to match these as part of our regular expression? The way to do this is just like escape characters. You just add a backslash in front of it. So say we wanted to match, we got a string that equals star password, and we wanted to match that. And we can go res equals string dot match, and then we want to escape that star. So then we put slash star, and we can add password. And so now it'll search star would become a character literal. You can see we get entire password versus if we had star, then it wouldn't mean anything because it's not being applied to anything. So it actually JavaScript would think we're using a string. So I can uncomment that C, and you can see that JavaScript thinks we're using a string. The next thing after quantifiers that is worth checking out are character classes. These make it easier to specify the individual characters. So right now we've been doing one at a time like ABC, but what if we wanted to look for a range of characters? And that's where we can use character classes. So as you can see here, we're using square bracket notation, and you can either do the list of characters you want, such as X, Y, Z, or you can do list of range, which is separated by a hyphen. So A through Z. So let's test these out really quickly. Say string equals ABC, and then res equals string dot match. We'll just match, do A and B, just to show that it doesn't match C. And so that means star means we're going to do 0 or more of AB, and it's greedy, so it's going to try to fill as many as it can. And it could be A or B every time. So this could be A or B, and we see it's A, so that'll be included in the match. Move on to the next one. This one could be A or B, it's B, so we'll move on to the next one. C, we see that it's not part of the character class we're looking for, so we'll stop here because we can't go any further. And you can see our results AB. Now let's try the same thing, but let's use a range. So we can do maybe A through Z, and this will capture the entire thing, ABC, just like that. And now, thing is, what about if we want to include the hyphen inside of this list? Well, we can do that. We just have to include the hyphen before or after the Z, or before the end of the last bracket and after the beginning of the first bracket. You have to do it right after those. So let's say we wanted to do dash ABC here, then we can add a dash here, or we could add a dash to the end, either one, a hyphen, sorry. And you can see we get hyphen ABC. What about everything? What if we wanted the character class to be everything but the range we specify? So that's really easy. Say we have string equals GEF, and then we want to match everything that's not ABC. We'll specify our ABC, and then all we have to do is add a caret symbol to the front of it, and that'll mean the opposite of whatever follows it here. In this case, you see we're just getting G, and that's because we don't have the star here, and now we get GEF. The next operator we should look at, our character class, is the dot, and this will match everything that is not a white space. So this is really helpful when you have two delimiters and then you want everything between those. So let's say our string equals an angular bracket, ABC, and then another angular bracket. We want everything between those. We can do that by using the dot. So we want to start with this angular bracket, the left angular bracket, and we want everything between that. So we use dot star and then end it with the right angular bracket. And just like that, we get ABC. with the angular brackets. What happens if we want to match the dot? You can do this either by escaping the dot, or you could include the dot inside of the bracket notation. So just to quickly do it, want a string equals a dot b, we do result equals string dot match. Then we want we want to include the dot, so we'll just do bracket notation like that. And you can see we got it now. Next thing is that there's a quick notation for specifying ranges. So you can do /d, which will specify 0 through 9, and then you can do /w, which will do lowercase a through z, uppercase a through z, and then also the underscore, and you have \s, which will just do basic white space. So it'll do spaces, it'll do new lines, tabs, returns, stuff like that. And so we can do an example of this. We can do string equals a, b, c, and then result equals string dot match. And we'll just match all w's, or all characters. This is usually referred to as words, because w consists of lowercase letters. There you go, we get ABC. All right, and the next thing to consider is, just like before, we could use the caret symbol to do the opposite of those character classes. So we can do the same thing and just do the uppercase version. So for example, the opposite of numbers 0 through 9 would be a capital D, and the opposite of the words would be capital W, and then capital S for the opposite of the white spaces. Final thing worth covering in character classes is a pipe symbol. What this means is the regular expression will look for X or Y, and it'll look for X before it looks for Y, and if it matches X, then it'll look at whichever one comes first. So if you have, we'll do an example. If you have string, lion, and bagel, and then we want to match lion or bagel, we can see which one it'll do first as a test. Lion or bagel, and lion comes first, so it'll match that before it matches bagel. Now what happens if we swap it? This time bagel comes first in the string, so it'll match bagel first. So this is really helpful when you need to match one or the other, and it's an inclusive OR, so it could match both of those if you're using the clean closure, the star. The next thing we need to consider is assertions, and these basically are about tell you about where you want the position of the regular expression to be. So the first thing is the caret. This is different than the caret we saw before. Instead of saying the opposite of whatever we've done, this will actually say the regular expression should come at whatever it precedes will come at the beginning of the string. So let's say we have a string equals ABC, and we want to make sure that A comes first in the string. Then we'll use this caret A. So we have result equals string dot match, or I guess we can use we'll use match. And so we can do caret A, and you'll see that it'll just match the A. That's because that's all we've searched for. But if we do caret B, it'll return null because B is not at the beginning of the string. Similarly, for X here with the $sign after it, it's saying whatever precedes the $sign should become at the end of the string. So in this case, if we want to make sure C, or if we want to check whether C comes at the end, we can do that here, and we can see we get a result, so it does. But if we do B again, B does not come at the end, so we'll get null, which means that B does not appear at the end. The \B is for word boundaries, and so when you're checking for a word, you'd want to make sure that when you're checking for a word, you want to make sure you're checking either at the beginning of the line or between a space or at the end of the line, and that's what the /B does. So let's see an example. A world with space at the end, and we want to see check whether LD is part of a word, and if it's part of a word, then as you can imagine, whatever is after LD would be either a space or it would be the end of the string. So we'll see that. So we'll want LD, and then we'll use \b. This will match LD because it is at the end of a word. But if we say, for example, did RL, it won't match because what comes after RL is considered a word. It's part of the /W we saw earlier. So it will not match. Similarly, if we wanted to check like at the beginning of a word, WO, this is at the beginning of a word because it's actually at the start of the string. So you can see we get WO. Now the \b, as you guess, is pretty much the opposite, and it's checking whether it's inside of a word instead of, or it's checking to see whether two consecutive characters are of the same type. Which, if you think about this, if you have a string like world, if you're using the lowercase b, then you're truly checking at the end to make sure that whatever you're looking at comes either at the beginning, the end, the beginning, or the entire string itself. Whereas the capital B, it checks to make sure that the consecutive items that comes after it are the same as what you just checked for. So we'll write a quick example using the same world. So let's say res equals string.match. This time we'll do OR with a capital B. And so since OR is inside of a word, because what comes after it is also a quote word character and before it. And so you get OR. But if we did LD, we can see that after LD it becomes a non-word character. And since it isn't the same as what we just checked, which is a word character, then it won't match. We can see it's null. So basically you should use B when you want to check to make sure something's part of the word, either the entire word or at the beginning or end of a word. And then /B, you'd want to use it either to check inside of a word or non-word characters. As part of assertions, you can also check, this is called looking ahead. And so what it'll do is X will only match if immediately after it is Y. And then Y will not be part of the match. So an example of this is, say we have lion bagel again. We only want to match if lion appears with bagel coming after it. So we'll use the look ahead syntax. We're looking for lion, and then the look ahead syntax, we're going to define Y now. And Y is just going to be space bagel. And you can see we get lion. But what if we remove one L from this? And it won't work because the bagel here does not match what we put inside of the regular expression. And then the opposite of the look ahead function is the negative look ahead. So if bagel does not immediately appear after lion, then it will match. And so if we take something here, but we add an exclamation mark where the equal is, and then let's remove an L, we can see that we do get lion because this does not match where we have in the regular expression. And then just like we can look ahead, we can also look backwards. And so here you can see we have X this time following the group right here. And so this time we'll look for bagel. We'll match bagel only if lion precedes it. So we have lion space, and then we're looking for a bagel. And there you go, we get bagel because lion, when we look backwards, it's there, it precedes bagel. And then the same thing here, we have the reverse, where if lion does not precede bagel in that exact, as it is exactly specified, then we'll get null return because we did not have a match. One of the final things we'll look at are groups and back references, and these are pretty powerful because they allow us to make our irregular expressions more modular, or like split them up into separate components in a way. Let's take a quick look at an example of groups. So let's start off with the string, and this time we'll repeat some characters. So 0001111, 0001111. Previously, if we wanted to match this entire string, we'd have to do 0 star, or we'd have to actually, we want it, so we could do 0 star, 1 star, followed by 0 star, 1 star. So that would be 4 clean closures. However, let's see if we can do that better using groups. We'll do the match statement like usual on the string. And then when we're creating the group, we'll use a parenthesis, and we want to match zeros, we want to match ones, and then we want to do that over again. So just like that, we define a regular expression inside of the group, which is 0 more zeros followed by 0 more ones, and we're also going to do 0 more of those themselves. And you can see we matched it 0, 0, 0, 1, 1, 1, 0, 0, and then you're seeing an extra thing here, and this is because groups have a memory associated with them. So whatever they match inside of the group will actually be stored as part of the return value, which is an array that has an object groups in it for when we start doing named groups. So remember 0, 0, 0, 1, 1, 1, which we can use later. So let's look at the name groups now. Say we use this same syntax, but this time we're going to give the group a name. And the way we do that is with a question mark, and then inside of the angular brackets, you just give a name. So we'll just call this my regular expression, just like that. And this will return an object, and we'll be able to search for groups. But we can actually just do groups, and then my regular expression. So when I run this, it'll return a group called myRe, and it will be inside of the groups object. And then so we can see that we're turning that group called myRe, and it's not being just stored in a array anymore. It's actually part of an object now. Next thing we can do is we can do the same thing, but if we don't want to remember what we used, we're just using it for like kind of the modular capabilities. We can add a question mark and a colon, and then it won't remember that. And you can see we don't have that extra output that was up here. And so the powerful thing about remembering this is that we can use them for later. So say we want to just match, we're just matching one of the groups. So we won't use the clean closure. Actually, take this away. We'll use a \1. And what this is you count the left parentheses of the groups. And so we count this, we see 1. And so if we want to refer to this one, we'll use \1. But if we had two different groups, they can be nested too. You still count from left to right. Then we'd have to change this number here depending on what we wanted to use. Once again, you can see that we do match the pattern and we don't have the star here. And that's because we're able to use the back reference is what this refers to. And we can do the same thing with named groups. And this one might be a little easier because you don't have to remember which group it was, which group number. You can just specify just the name. And then here you go. We do have it, and we can see the matched group just like normal. Final thing to look at are some flags you can provide to regular expressions, and these are actually, you add them after the regular expression finishes. So then the first one we're going to look at is D, and this will generate indices for the substring that you're matching. So as you saw, some of the strings we were just matching the first part, and then as part of this extra information, we can return a list of the starting point and the ending point. So let's do that right now. I want to match on word characters separated by one or more spaces. Now I'm going to also add the G flag, which we'll cover next. And I'm going to execute it this time, so it'll display extra information. And then you can see here we found 0, but then now we're getting this indices, which is new, and it's starting at 0 and it's ending at 4, but exclusive, because then you can use a substring, and a substring is exclusive, and so you just be able to plug in this variable, these values to get exactly what you want. And the thing about G is that moving on to this G or global flag, it'll save the stopping point. And so if we're going to call this function, if we're going to call this again, then it'll start from where I left off. And you can see now we have 4, 8, and that would actually be these zeros here. And then we can call it a final time, and we'd get 8, 11. So that's D and G. I would be case insensitive. So let's say we had a string that equals A, B, B, CC, for example, and we just want to just check to see whether the string is characters. And so we can do that by using the I flag. And so we'll just do A to Z, which you can see is lowercase. We want to get all of those, but we're going to want them to be lowercase. So we use the I flag, and then we'll run this regular expression using execute. and then you can see it still matched them, and it kept them in their original, how they originally were. The next thing is the M flag, and what this does is if we have a multi-line string that uses the new line, then it'll make the caret we talked about and the dollar sign, which were used. Caret was used for specifying something at the start of the string, and dollar sign was used for specifying something at the end. It'll make these also recognize the new line. So let's say we have a string that equals dog, cat, bird, and then we want to print out these. We can just do just the first character just to show how it works. So we'll just do it how you might think that it would work. So we'll match it. We said we wanted the first character, and we'll have it so that the first character is the start of each string. So we just do caret / w like this, and you'd think it would match what we want. So let's try it out. And you see we just get D. We don't actually, or I guess since we're using global, we'd have to call it multiple times. Yeah, see, we're still just getting D, even though we called it multiple times. So now let's add the M in here and see if that changes anything. And dog, bird, cat. Yeah, we get the second one because it calls it consecutively. So before we were getting the D, and now if we call it 3 times, we get the B because we got all the way down to the bird. And then the next thing is S, where we can have the period match new line characters. So if we have just string equals dog / cat, and then we have regular expression equals string dot match. This, you'd expect it to match the entire string, right? But we're only getting dog. That's because period doesn't match the new line characters. But if we add S, then it'll match them. And you can see we get dog, new line, cat. And then Y is for sticky, and sticky is kind of similar to the global. The only difference is that the global will, if it starts at index 0, if it's not been assigned something else, if it doesn't match anything, it'll move on to the next index. And it'll keep doing that until it finds a match or reaches the end of the string, in which case null would be returned. And then sticky, it'll start the index you give it, which by default starts at 0, and it'll look for the pattern, but it won't advance to the next index if it doesn't find it. And so we can see the example of this. We have @cat @ and then this time we're going to use global. This will return something because it will move on from the index. So if we're searching for cat, you see it won't find it at the first spot. So normally it would stop and not return anything. So we found cat when we use the G flag, but now let's try using the sticky flag. Y. Here we can see it did not find it because it doesn't move forward. So that's the basic of regular expressions. If you want to learn more, check out this link here by MDN, and then there's also a bunch of cheat sheets online to check out. But let's try a more complex problem. So for this one, our goal is to validate an email, and it's a simplified version. It'll be in the following format. We'll have the recipient name followed by the @ symbol, followed by domain name, and then the top level domain name. And here are the requirements. The recipient name must contain at least one of the following lowercase or uppercase alphabet 0 through 9, and then it can contain special characters, hyphen and underscore, but it can't start or end with any of these, and then you can't have them appear consecutively. So dash, underscore, or hyphen underscore, like that. The domain name requirements, the same alphanumeric as the recipient name, except here the special character is only limited to 1, and it doesn't have any specifications on whether it can appear at the beginning or end or be consecutively. And for the top level domain, we're going to only assume we're going to have 1, and it's going to be .com, and the email must end with that. So let's just create a function validate, and then work through some of the what we would need for the regular expression. So the first thing we see we're going to need is that we're requiring that we have one of these characters at the beginning. So I'm immediately going to create a class list of characters. It's going to be A to Z, uppercase and lowercase, and then 0 to 9. And so we check this off. We are able to guarantee that we have a one of these at the beginning of the string. The next thing is that we want to have, we don't have to have any more characters after this. But if we do, they can be any combination of the characters we just specified, or they can be special characters that must have a normal character after them. And so we'll do that next. And notice the or. So it can be a special character, it can be regular characters or a special character with a regular one trailing that. So this time we'll create a group. So we said it could be regular characters, or it could be a special character followed by regular characters. And then we said we could have 0 more of those. And so just like that, we've created the recipient part. And then we want to have an @ symbol separating the recipient part from the domain part. And for the domain name, it's the same letters. And then we can have 0 or more of these. And then we can also have a dash, so we'll add the dash at the end of here. Doesn't matter what order they're in, so we'll add the clean closure. And then we want to end with a .com. And so I'll wrap it inside of its own class and then add the $sign symbol to show that we want the entire thing at the end. And just like that, we've created a basic regular expression for this. And so we'll just log if it matches. And so if it's null, then it means it did not match. The regular expression did not match the email. And typically you'd want to call the test function, and then you could deal with the truth value from there. So let's just test it really quick. I have some test cases here. And you can see these ones are the good test cases. They're all valid and should work. Oops, running the wrong program. And then should use the right program name. And then here you go. We do get b@gmail, and then ba. We match the entire string here, and then finally there. So all of those cases are matched. And then for the bad cases that we don't want to match, we can try out some of those. And then we get all null, which means validate it did not match, the regular expression did not match that email, which is good because these are just some of the cases we don't want to consider. And so this will conclude our talk on regular expressions. But you should just realize that the test cases we've considered here aren't exhaustive. And I should also tell you that the power of regular expressions, because we don't need to produce a lot of code to cover checking a lot of potential inputs for validations. But it can be complex to consider the edge cases. A final message I would say is that one problem with regular expressions is that sometimes it's not easy to read. So having helpful names for either functions or variables will go a long ways, or simply having a comment describing the behavior rather than just like a magical regular expression that does something helpful. There are cheat sheets online you can check out. And then for common validation issues, chances are someone else has already created one, and it might cover edge cases you never even thought of. So it's worth looking at those solutions before creating your own. However, if your use case is something that has probably not been used for before or is not published online, then of course that would be when you should work on creating your own. Thank you and have a good day.